Son, I'm sorry. Why was the breakout room closed? Is this time to finish already?
Yeah, I think the third session should have ended at 3:20.
Oh, 3:20. Ah, okay.
And now we have a break time. You can just relax before the next session.
Okay, thank you very much.
Yeah. Sorry if it's unclear.
So, a little bit. That's okay. Thank you.
Thank you. Thank you for feedback. Okay, it's 3:30, and I would like to greet all participants of Life Science Retreat, students and faculty members, and special thanks to everyone who joins us on YouTube live stream. Welcome to the Tech Talk by Google Developer Student Club. And before we start our Tech Talk, I would like to introduce what Google Developer Student Club is. Google Developer Student Clubs are the communities of students who gather together to learn new skills and network and create impact. So if you are new to programming, you can learn basic coding skills, basic programming languages like Java or Python. And if you have some experience, you can then move to building your first mobile or desktop applications. If you're interested in data, you can learn how to retrieve meaningful insights using data analytical skills and machine learning algorithms. And how can we learn all these new knowledge? Google Developer Student Clubs have multiple activities, such as study jams, workshops, where you can get the real practical knowledge of how to code, how to create application, or how to run your first machine learning program. We organize tech talks like this one. We organize coding competitions, hackathons, and social activities where we can build the meaningful connection between each member. So talking about the details, you can earn skill badges, for example, by learning the Kotlin and getting through the whole process from basics to the advanced topics. You can earn certificates, for example, learn the Android basics in Kotlin and get the Associate Android Developer certification. And you can create real projects like apps with Flutter and then showcase your certificates in social media or resume. If you're interested in more creative skills, you can learn about the user experience design and get the professional certificate with Google, all by studying together in a group in our community. And there are many more skills that you can learn. For example, the Google Cloud, which is related to today's topics. Today we have a combined activity of a tech talk and the workshop. And the speaker is Minori Matsuda, who is a data scientist manager at Coca-Cola Bottlers Japan and one of the 6 Google developer experts in machine learning in Japan. We are all surrounded by lots of data. In academia, we create data ourselves. So it is important to perform an efficient data analysis and get the meaningful insights from data. Maybe you know that Japan is famous for lots of vending machines selling different kind of beverages, different kind of taste of coffee, soda, and water. Have you ever wondered, do these vending machines are placed randomly? Can we put it anywhere? Or how frequently do we put vending machines? And Coca-Cola Bottlers Japan analyzed the data from 700,000 vending machines in Japan. And they learned a lot from this data. So you will learn today what they have found. Before we move to the tech talk itself, let me remind you about the free coupon that you can activate by logging to the Google Cloud platform with your personal Gmail account and follow the link which I have provided in the Slack channel. You will need your credit card, but you won't be charged, so don't worry about it. And if you are watching us on YouTube live stream, you can use 90 days, $300 free trial to access the Google Cloud platform for free. And we have a question. Okay, we don't have a question. So if you have any question, please don't hesitate to ask here on Zoom chat or on YouTube live stream chat. And we will read your questions later on. So now we will start the tech talk itself. I will stop sharing here. Please, Minori Matsuda-san, you can start.
Okay. Hold on. Can see the screen? Okay. Thank you for introducing me and invite to this talk. And this session is about the Coca-Cola how Coca-Cola analyze the data, the real world data, analyzing and processing, and find the insight and make an impact, the social impact to how to make a social impact through the machine learning. So please relax and yeah, lean back and listen my session. Okay, so first of all, who am I? My name is Minori Matsuda, and I'm a data scientist manager, and statistics and analytics and machine learning is my profession. And as she said, I have said, I'm the one of the Google developers expert, and only 6 people in Japan, especially in the machine learning area. And I'm working for 15 years, over 15 years, the retail industry. And oops, sorry. And I hope everybody knows about Coca-Cola. Maybe, perhaps everybody knows Coca-Cola, but let me introduce my company. And as I have said, our company has 700K units of the vending machines and 15,000 the trucks they're operating every day. So there is a lot of the need to improvement from data and insight, and because this is perhaps the Ryugakusei from other country was surprised when come to Japan, too much vending machines. This one is maybe only in Japan. This market is only in Japan. So yes. So, and I will talk 30 minutes and or 40 minutes, and after that Q&A, I would like to interact with you, the student and other guys. So what is machine learning? And in here, have you ever used machine learning? If you have ever used machine learning, please raise a hand from the reaction. No, cannot. Oh. So not so much. Oh, okay, thank you. Not so much. But so I start basically concept of machine learning. The machine learning concept and the deep neural network, maybe everybody here heard about the deep neural network, the deep learning. If let's make machine recognize numbers, we need to prepare the data and the labels. This is the training data. Then the data put into the network, deep neural network. I will mention later, the put in the network and the training. After that, the machine recognize this is 0, this is 2, this is 4. This is the basic concept. And what is doing inside DNN? And DNN is really simple concept. Left above chart, there is the input layer, and send forward to the each neuron decision to the send to the forward, and finally output layer. And if the result is wrong, was wrong, the back propagate to the behind the hidden layers, and then adjust the weight and bias, only weight and bias. And each neuron has, and usually currently the model is over 1,000 hidden layers, currently model, and uncountable neuron inside. But this neuron is just a metaphor, not unlike the brain cells. Just we call that it's neuron, but inside just adjust bias and weight and bias. And training after many iterations, machine finally can answer the correct answers. So, and why people shout about deep learning is these simple structures can solve many problems. Maybe you guys will know about AlphaFold. This is the protein structures prediction. This is also from deep learning. So the deep learning can solve the specific tasks can solve really well. And have you ever tried deep neural network here? Please raise your hand. No. Oh, one. Okay, only one. So this is good beginning. Okay, thank you. Yeah, and yeah, surprisingly, this simple structure can solve the many problems. And deep neural network requires matrix operation, and this is a really high cost, the calculation. So if the left above if you calculate CPU only, it's only against to use the GPU or TPU, tensor processing unit, the image 250x faster. So if you don't have GPU, maybe use SOKENDAI one. Ask the professor. Maybe I assume the university, the graduate school has many computing resources. So I strongly recommend to use the GPU or TPU. Okay, next. And the machine learning has various algorithms. So not only the neural networks. Neural network is only just one of the algorithm, but there is many algorithm. Also, everybody knows linear regression or PCA, principal component analysis, or support vector machine, NIBB, like many algorithms can solve where the specified problem. So you don't need to master all of these. Just dive deep into one algorithm. If you want to learn the deep learning, maybe you should learning deep about the deep learning. Okay, then I speak a little bit fast. Okay. And how to approach to the problem and the common mistake. And I'm from the industry, not researcher, but I really often see this kind of mistake. The long case is, oh, this is a difficult problem, so let's find algorithms that can solve the problems. This approach is sometimes most of the time cannot solve the problem because the problem is too difficult. So the more near close way is I'm good at this algorithm. So let's find the problem can be solved the algorithms. So just the approach is find the low difficulty problem and the high impact problem. Maybe you guys approach is also same, but in machine learning it's also same. Learn algorithm and then find a problem that I can solve. That is the closest way to the quick output. So, and I will show the example of the visualization, what we doing on our companies to, can I see this map? No?
Yes, we see.
Okay, this one is before COVID and after COVID, after COVID, the human traffic analysis. And the yellow one is less human traffic than before Corona, COVID. And red one is the population was increased after COVID. So let's take a look in Tokyo. So Tokyo 23 ward inside, nobody in the lunchtime. This is a lunchtime traffic. This is a lunchtime traffic. After the COVID happened, nobody in the office or school. So nobody in the Tokyo 23 ward. But people move to the Shonan or Kamakura or somewhere because everybody can work from home. So everybody work from home, so Saitama or Chiba. So they are always stay in the home in the lunchtime. This is the one of the simple analysis of the analysis and visualize the social movement. And this one is the how we place the vending machine. This is the real data, and usually I don't show this one, but this is a university educational event, so I show it. Okay, which area? Ueno Shibuya. Okay, we go to Shibuya crossing. Okay, Shibuya. Okay, this one is the Shibuya. And this red star is, can you see the pointer? Okay, this red star is the actual sales. This one is the 1,600 case of sales. Then 3 Coca-Cola machine here. But we predict the 700,000 data learning by machine, and the machine is predicting the 200 million point of the Japan, the grid. So the machine says you can put one more vending machine here. Then the prediction sales is 300 cases. So there is another opportunity. This here behind the building like this, and we don't put the vending machine randomly, just analyze and the prediction of the human traffic, and also point of interest, like there is a school or there is a stadium or there is a station, or like that kind of all of the information gathering and learning but to the machine. And then we solve the real problem. And okay, go next. And we also doing the visual recognition, vision recognition. Our staff taking a picture of the vending machine, so it automatically recognize the price and the product, what product selling in what price. So, and capturing to the data, and so we can decide. We put the truck driver rest station, we put many coffee or like that, we can make a decision. Okay, and next is from the Google. So for the beginning, I recommend you to use the Google Cloud, the Vertex AI. This one is everything including, and you guys must have coupon now, and the vision and the video and the conversation and the natural language and the structured data. There is AutoML. I will explain AutoML or explainable AI or many tools inside here. So for the beginner, just 3 steps: the preparing data and train the model and get prediction. Prepare data and train and get prediction. Only these 3 steps. And there is also AutoML. If you are not familiar with Python writing the own code from scratch, there is the AutoML image, AutoML video, and AutoML text, AutoML. Maybe translation you don't need it, and AutoML tabular tables data. And the AutoML vision is like this. This one is maybe if your data is like the human a body cell running the vision data. This another example is now this AutoML vision is for diagnosis for the brain cancer or something, like from X-ray, and this point is the cancer. The machine is really accurate. So if you have a lot of data from microscope to put on the AutoML will find something different things, because machine looks different features, not like unlike human. When machine recognize this is a pizza, this is okonomiyaki, is a human usually look the what is put on the plate, like the sausage, or like the sauce. If the sausage or pepperoni, it's a pizza. But the machine looks the edge of the pizza and the okonomiyaki, then recognize. So machine and human is totally different recognition system. So maybe you might find something different from the machine learning. And also, if you want to work, if you want to write the Python, if you learn and write the code by Python, there is a workbench, the full managed Jupyter Lab, so you can easily to write the code on the production. And yeah, this one is a cloud credit from Google and $100 per person. So maybe you should budget alert. If $100 you set budget alert, maybe you don't need to pay anymore. So yeah, $1 per person. So it's worth to try, I think. Okay, I talk 27 minutes. Okay, this is Q&A time. Please raise your hand and feel free. Any casual question is okay.
If participants from YouTube live stream have any questions, please write in the chat and we will read them.
This is on the YouTube?
Yes.
Really? So I cannot see the question. Okay. Or raise hand.
Okay. We have one question from YouTube now.
Okay.
How long has this work being carried out in Japan?
Well, how long from the gathering data or start machine learning prediction, which mean maybe start machine learning is 2020 the maybe it's October or something, and I create a model in 2 months, only 2 months. So only 2 months you can create the model. If you are really good to know the domain knowledge, your specified knowledge, if you have strong knowledge of the data, so it's easy to make a model.
Thank you.
Okay. Oh,
Okay.
Bim-san. Okay.
Please unmute yourself.
Thank you for the wonderful talk. So I was curious. So if I want to share a machine learning model with some other person, so does the data which the machine learning algorithm already learned will also be transferred, or that person has to again rerun the entire process?
No, if you create a model, the model is independent from data or prediction. So you can provide only the model. Once you provide them, once you create the model, you can share the others. And there are many methods, but yeah, model is independent itself. No need training data. If you complete your model, if you make the 99.9% accuracy model, so you can provide to your classmate. Yeah.
Yes. Okay. Thank you.
Welcome. Anybody? Maybe.
Okay, we have a question. You can read also in the chat if it's unclear. Regarding the comparison of the movement of people during the launch pre and post-COVID, overall, did people start moving more post-COVID time, except for Tokyo area and somewhere around Niigata region?
Niigata region, wait, regarding a comparison movement, the launch play and overall this stuff, more possible. Oh, yeah, before Omicron appears, the people move for lunch to the city area. This is a Niigata. Niigata is like this. I don't know which is Niigata station, but maybe here is the Niigata main area, or I don't know. Yes, people start to come back to the Tokyo or capital area. People resume to work in the office, and yeah, start to dramatically changing. But after the Omicron news, the people go back to home again. But the vending machine cannot move only 1 day or 2 days. So we need to plan to decide 3 months before, or to predict 3 months ago, 3 months later, or 4 months later. But it's nearly impossible to about the COVID, the positive case number is even Google or even the National Institute cannot predict, right? So WHO, so I don't think I can predict the human traffic. Just I use the current human traffic. Is this make sense?
Yeah, I think it's clear. So
Okay.
Comparing the movement before COVID and post-COVID, now you have maybe data after the COVID. Overall, people moved more
Yeah.
during
So
the post-COVID.
Olympic, during Olympic time, everybody stay in the home and everybody didn't go out. So we Coca-Cola have a lot of investment for the Olympic sponsor, but nobody watch it on TV. Yeah. Okay. Okay. If
Okay.
there is another question, and
can I ask a question?
yeah, of course.
I'm curious about the theory of deep learning, and actually I currently study the mathematics behind the model, but as far as I hear your story, there's no need to know the theory. So is there good things to know the model behind?
It's good. It's really good question. If you don't know the car engine structure, how engine works, but you can drive the car, it's like this. But if you know the inside of the mechanical of the engine, you can do it more better. So I mean nothing unnecessary. The theory is it's the basis. Theory is the basis. Of course, the understanding theory is the really great thing. And but I just simplified this session. I try to make a simplified the session so like the deep learning is easy or like only put data, but actually the behind that there is many mathematical models. So it will be connected at some point. Is it?
Okay, thank you.
Okay.
So,
yeah.
So when you need the knowledge, so tuning the parameter.
Tuning parameter. There is now currently the hidden layer is too big. Now the model, the current number one model from Facebook is the maybe 3 billion parameters, and it's impossible to tune in by human 3 billion parameters. So machine with automatically tuning, trying iterations, trying the learning rate or dropout rate, then tuning one by one and try and fail. And so that's why the need the calculation power. But very basic experiment, maybe you can adjust the parameter how it works to understanding the structure, what is the behind of the deep learning. But yeah.
Okay, thank you so much.
You're welcome.
Let me just read one question from YouTube, then maybe then Beam will ask question and then another question from YouTube, okay? So the first question from YouTube, sometimes it's really challenging to find big data to teach some models. How do you think, are there any possibilities in the future that neural networks will work with much less data?
Okay, this is also a good question. I guess all of you saw the fake news or fake unreal human, created unreal human face or like that. So if we have not so much data, we can create the similar data. This is advertiser, I forgot the name, or data argumentation. We have a data argumentation method is if you have the one image, It's like the change color or change angle and learning the different data. So to or distortion, make distortion to learn to make more data. So there is a way if you only have few data, and currently the self-learning method is self-learning method is do you know there is the chess or Go or shogi. That is a self-learning, self-supervised learning. There is no training data. The machine and the machine fight against the million time. Then the champion model win against the human. So there is the machine never learned any data, any past data. So there is a way if you have only less data.
Like reinforcement learning, you mean, right?
Yes, reinforcement learning, say RL. Yes, it's like the dog learning like that. Okay.
So my question is similar to Ito-san question. So like in when I do some analysis in that, there might be some false positive, same like if we cannot tweak it, so can we teach the machine learning to do statistical test or something?
Yes, it's like ROC curve or false positive. It's the statistical output. You can see the result, the accuracy. That it's a trade-off overfitting or underfitting. It's a trade-off, but you can confirm the result, how the model can apply widely.
Okay, that's all. Thank you.
Okay. Yeah. Welcome.
And we have one more question. So we have some participants from Kazakhstan, and they are interested. Is this kind of work done in other countries, like, for example, Kazakhstan or other countries?
Oh, yes, kind of store location, which place to open the pizza shop, or like store location we can use for machine learning store location, or Kazakhstan. I don't know about Kazakhstan well, but
many other countries, like in America,
many other countries,
Australia.
US, Australia, yes. But many countries have many behavior, not like Japan. The American drive the car and stop by gas station, and at the same time buy the coffee. But the Japanese is walking and to find the vending machine and press the button. So yeah, there is, but every country has every different model. It's like the Arabic country. Arabic country is more interesting models. The Arabic country, the temperature gap is really highest temperature, and the lowest temperature is really extremely. So the temperature change and the demand prediction is it really works well in the Arabic country like that. And every country has every unique model. So every your research must have every different model. So it's interesting. Okay.
Thank you. I have actually a question related to this. So do you collaborate with behavioral scientists that study human behavior to place these machines, analyze the data?
Human behavior is so before the machine predict the where to place the vending machine, the human, the business developers walking around, and maybe here will be high sales like that. But after my prediction model was deployed, the human think the reason why this AI predict the high possibility sales here. So human follows AI now. I mean, is this answer? What what was the original question?
Do you collaborate with scientists that study human behavior?
Nope. Because human behavior is more dynamically like the SNS. You saw the Twitter something good. Oh, I want to buy it, but it cannot measure it now. So, and only we can capture the click or not or something like that. But the human behavior is like suddenly I want to buy Coke or something. So not yet implement the human behavior data.
Yeah,
And
so it's
sometimes
too advanced, right? To predict human behavior.
A little bit too complicated.
Thank
And
you.
it's all about the marketing, like the what idol group shows on the Coca-Cola advertisement with high impact. It's like the marketing. It's like marketing. Okay.
Thank you.
Yeah.
Do we have other questions from Zoom participants or YouTube live stream participants? And if not, maybe we can have a small demo of how to about the Google Cloud Platform. Could you show, for example, the products and how to access the model or the data? Yeah, maybe you can like show the small demo for students to try.
Okay. Hold on.
So if anyone from students didn't activate their coupons, you still have time.
Okay. Yeah.
We will try to show you a little bit of the platform.
Okay. This one is a real console. This one is real console. Hold on. This one is a real console. If you enter the console, you can see this screen, and this one is my project. And go to here, and this one is the Vertex AI. Click here. And then this one is the data set. This one is a data set. Yeah, Coke trained is a data set and train model. Maybe create the data set is like create data set. Okay, this one.
Can we do it a little bit slower? We have a feedback from students.
Okay.
So if students are joined the Google Cloud Platform, you should have this interface.
Yeah, interface. This one interface and redeem the code. You should make the project your own project, like.
Yes, Google Cloud Platform.
Yeah, go to Google Cloud Platform, and this one gets started for free.
Or if you redeem your code, you can click the console, and this will be your interface.
No, you need to register the credit card first. It's like this billing account. your billing account will be here, and you register. You have to register the credit card, and after that, redeem the code. As the Google Racer mentioned, to redeem the code, then you have the billing account. Your billing account has the $100 the coupon. And yes, and this one is the payment setting. Payment setting. It's like payment ID and the payment profile, and yeah, name and address. And
So if students have activated their coupons following the instructions,
yeah,
so we already sent the instructions. Then
okay.
from this 3-line menu, you can find the Vertex AI.
Okay, okay, but Vertex AI.
It should be in the product section, right?
Yeah. It's actually in the VVVV. It's like below the AI product is below, like this big data. This one, AI,
artificial
AI.
intelligence. So under artificial intelligence option.
Yeah, yes. Then go to dashboard. I already have the data set and the models that this model appears, but you start to click the data set, and you create the data set to training data. What kind of training data you define first? Like if the image classification single label, image classification multi-label, or image object detection, or image segmentation. This for data set is for images. And if you have tabular data like the tables, like Excel or something, tables data, regression or classification, or forecasting, the future forecasting. And maybe this one is not so using text classification, or text is also text analysis is maybe you will not use so much, but there is also text like document AutoML, and the video action recognition, video classification, video object tracking. And so if you observe and recording the microscope and like something movement, put this video image, and then create. After create a data set.
Yeah, so once students, if you decided what kind of data you want to use, then you click on create data.
Yeah, create data. And there is the, make it bigger. If the video, upload video from your computer, upload import files from your computer, select import file from cloud storage. There is a 3 option. If the file is too big, there is a storage on the Google Cloud, you can choose it. Or upload file like this, and select the file and upload. Then dataset will be importing to the other dataset. And
so do you have a pre-processing step before uploading the data?
Not so much, and not So data cleansing, if the comma point is different, maybe you need to clean up, but cleansing. But most of the case that you don't need to prepare the data like feature important feature engineering, feature engineering. Yeah. So okay, let's make the picture. Okay, if we make a data set and then make model, no training. It's like the create training and so AutoML, and AutoML Edge and the custom training. This one is the scikit-learn or XGBoost or many Python famous popular library. If you want to customize training, you would like to choose this. But most of the case, the AutoML works. And the AutoML Edge is for edge computing, like the automatic driving, the edge device detection, the object detection. So this is AutoML and the video action recognition and the continue and training and test percentage random assign. Then start training. That's all. Then training will start. And after the training finished, you will get the notification. Then you can see the model here, like this one. This one is confidential, but I show it. Like this, the model evaluation will come out like the RMSE or R square, like that, like this one, or feature importance. Wait. One. Oh, like this. This one is the house. This one is the cargo house price prediction data is the human. Then the future importance. What factor? What variable is the contribute for the house price? It's like the top is the living area. Residential area is the high contribution of the house price, or neighborhood, or like fireplaces, garage cars, like that, year built. So you can find you can see inside the model how it has high accuracy. This one, the R square is 0.9. This is really high accuracy. So you can believe this. So this one is the tables AutoML. And after auto model done, 6 minutes left. This one, batch prediction.
So we have one question. Can we train using just one image?
Just one image is maybe minimum is, I forgot, but the minimum is maybe 100, or need to make annotation. This one is A, this one is a B, this one is a C. Need to make annotation, but yeah, not all. You cannot do it. Machine cannot learn from only one image.
Okay. Yeah. And if anyone has question, can we approach you on social media like LinkedIn about the Google Cloud Platform? So we will provide the social media links for anyone who tries this Google Cloud platform after the workshop. And if you have any questions, don't hesitate to ask Matsuda-san or join our community to learn about Google Cloud, about programming, anything related to technology. And we have a question from Adil. And if you have any questions, please just ask, unmute yourself. For example, Adil is asking how powerful should be the computer to use the platform.
This is the computing on the Google huge machine center. So you can train even from the Android tablet or something. So you don't need to worry about it. Just only needed web browser like Google Chrome. Only that. There no need the powerful PC or no need GPU. You can use the Google one.
Yeah, that's the advantage of computing in the cloud.
Okay, we have. Okay,
yes,
Node hour is it's a budget. It's budget. It's if you only have $100, maybe you can run, I don't know, maybe 100 hours like that. It's a budget. It's a learning time. But if the model is fit perfectly, the machine will stop the learning to predict overfitting. So yeah, it's a budget, about the budget. Okay.
There is a possibility to calculate the possible amount of money your training will cost, right? There is a calculator, price calculator.
Yeah, price table. There is.
On the Google Cloud platform. And you can predict.
You predict. Yeah. You can predict it. Estimate the cost.
Yes.
Or ask to the Google another credit again.
Yeah. So if you're interested, we can organize the study jams and learn in detail about the machine learning analysis on Google Cloud. And we have 2 more minutes before the end of our tech talk. And I want to thank Minori Matsuda for helping us organize this event, sharing his expertise in machine learning, the approach to machine learning problems. And I also want to thank everyone who joined this session. Thank you.
Thank you. Thank you very much. Bye.
Thank you for organizing, Ayas-san. From 5 p.m. We will start invited lecture by Dr. Miki Ebisuya. So please wait for until at 5 o'clock p.m. Thank you.